All right, everyone. Today we are going to take a look at solving absolute value equations, but we're going to look at ones that have a number outside the absolute value. So a quick recap of solving absolute value equations. Give this problem a quick try, pause, and then come back. All right, so just to recap to make sure we know the basics, remember you're not changing any of the symbols in here. All you're doing is setting up two equations, one equal to positive 17, one equal to negative 17. You're then subtracting 3 from both sides and dividing by negative 2. We get x equals negative 7. And you're subtracting 3 to get negative 20 and dividing by negative 2 to get positive 10. And those should be your two solutions, okay? But what if numbers in the equation are outside the absolute value? So here's the scenario I want you to think about. Let's say that we had 3 plus the absolute value of something is equal to 7, okay? I want you to think about what number or numbers could go inside of this absolute value right here, just single numbers. What number or numbers could go inside of that absolute value? Hopefully what you said is the numbers 4 and negative 4. And what's interesting there is our equation is actually equal to 7. So usually when you look up for A, we set those two equations equal to 17 and negative 17. Unfortunately for here, what we did is we can't do that. So what is the process here? Well, the process is going to be really simple, okay? You are going to get the absolute value alone first by adding, subtracting, multiplying, and dividing other numbers, okay? And then you're going to set up two equations, okay? So here's what that would look like if we look at example A. We're going to do this one together, okay? So what you would do for A is you would subtract 3 from both sides, and you'd get negative 2x plus 3 in absolute value equals 15. What this is telling you now is my absolute value is actually equal to 15 or negative 15, not 18 and negative 18. So you're going to set up negative 2x plus 3 equals 15, negative 2x plus 3 equals negative 15. You're going to solve both of these. I get negative 2x equals 12. I get x equals negative 6. And then I subtract 3. X equals negative 18. Divide by negative 2, and I get x equals 9. Okay, so again, I'm getting rid of this number first, and then after that, then I'm setting up my two equations with this new number that's over here by itself. Let's do the same thing for B. So to get rid of multiplication like that, okay, you would divide both sides by 4. Okay, similar to what I'd do if that absolute value was just a big giant variable, like if it was 4x. So I've got the absolute value of 2x minus 1 equals 4. And then again from here is where I'm setting up my two equations, right? So 2x minus 1 equals 4. 2x minus 1 equals negative 4. And then I'm adding 1 to get 5. I get x equals 5 halves when I divide by 2. I'm adding 1. I get 2x equals negative 3. I'm dividing by 2. I get x equals negative 3 halves. Okay? C is a much more challenging example. You've got to get rid of both that 3 and that negative 2 first. Let's see if you can figure that one out on your own, and then we'll go through it. All right, so to get rid of those two numbers, what you needed to do is subtract 3 first. That's going to leave you with a negative 2 times 4x plus 3 equals negative 18. Then you're going to divide everything by negative 2. That gets you the absolute value of 4x plus 3 equals 9. Okay, now's the point where you set up your two equations. So 4x plus 3 equals 9. 4x plus 3 equals negative 9. Again, you're waiting until the absolute value is by itself to do that step. You get 4x equals 6. X equals 6 over 4, which is the same as 3 over 2. And then you get 4x equals negative 12. X equals negative 3. So really the only difference between solving an absolute value inequality, a regular one, is just that you have to get that absolute value by itself first before setting up your two equations.